Hello and welcome to this screencast on the mechanics of breathing. Okay, so we started the respiratory system last week and we looked at the structure of the respiratory system by the screencast we did. In next lesson we're going to be looking at the mechanics of breathing. So first of all, before we actually start, this is the structure of the respiratory system that we should know now with regards to potentially filling in any blanks, identifying them on a diagram, or being able to say some of the functions of each one. So please just recap yourself with this. You can pause it, kind of write down what you think the functions are, etc., and then check with your notes. So with regards to today's lesson and the mechanics of breathing, we need to know what the thoracic cavity is. Now, the thoracic cavity is everything right there that is in front of you on that screen. It's pretty much the respiratory system with regards to the chest area, so going from all the way down from the diaphragm to the ribs, and including the trachea as well. So that is a thoracic cavity right there. Don't necessarily need to write this down, you just need to be aware of it, because the thoracic cavity becomes a term that we are going to be using during the mechanics of breathing. So what do we mean by the mechanics of breathing? What we mean is inspiring air, so breathing in is known as inspiration, and then breathing out. So we breathe in air, oxygen, etc. We breathe out carbon dioxide. Breathing in is known as inspiration, breathing out is known as expiration. And we need to know how this works, the mechanics behind us being actually able to breathe in air and being able to breathe out carbon dioxide. So first of all, we're going to talk about inspiration. So what I want you to do is to get your notes set up with regards to talk about inspiration. We're going to write each term down, then you're going to create a question for each one. So first of all, inspiration is breathing in. So what happens? First of all, we have this muscle here known as the diaphragm, and as you can see at the moment it is a dome shape at rest. So at rest the diaphragm is a dome shape. When we breathe in, what happens is the diaphragm contracts and it flattens. So rest, got a dome shape. When we breathe in, the diaphragm contracts and it flattens. So when it contracts and flattens, we also get the external intercostal muscles contracting, which remember were in between the ribs. So the diaphragm and the external intercostal muscles are muscles and they contract during inspiration. What this means is the ribs move up and out. As you can see here at rest, actually quite a small area here, the thoracic cavity volume is quite small. Here you can see how it's much larger, and this is because the diaphragm is contracted and flattened. The external intercostal muscles have contracted. The ribs have moved up and out. This means this thoracic cavity volume has increased. Because the thoracic cavity volume has increased, i.e. the area in that is larger, this means the thoracic cavity pressure, the pressure within our thoracic cavity, that has now decreased because of the amount of volume and space that is around in there. So the thoracic cavity pressure decreases, which means that air rushes into our lungs. That is how we breathe in. Our diaphragm contracts and flattens, our external intercostal muscles contract, our ribs move up and out, the thoracic cavity volume increases. This means the thoracic cavity pressure decreases, which means air rushes into our lungs. So for each one, my question may be, which muscle contracts and flattens during inspiration? Diaphragm. As well as the diaphragm, which other muscle contracts? External intercostal muscles. What happens to the ribs during inspiration? They move up and out. What happens to our thoracic cavity volume during inspiration? It increases. Thoracic cavity pressure during inspiration decreases. Where does air go during inspiration? Rushes into the lungs. They are the questions that I want to have, something similar to that. Okay, so with expiration now, expiration, it's the opposite. Okay, so the diaphragm just relaxes and moves back up. So if we look at expiration now, breathing out, the diaphragm, it just relaxes and it moves back up, as you can see in this photo, or diagram I should say. The external intercostal muscles just relax. The ribs move down and in as opposed to up and out, so they move down and in. Because they move down and in, look at that volume there, it's decreased. Okay, so the thoracic cavity volume decreases. Because the volume has decreased, this means the pressure in there is greater, so the pressure is increased, which means that air rushes out of the lungs. So it's just the opposite to inspiration. So for expiration, the diaphragm relaxes and moves back up. the external intercostal muscles relax, the ribs move down and in, the thoracic cavity volume decreases, thoracic cavity pressure increases, air rushes out of the lungs. Okay, again, so when it comes to questions for this part, I may just say, okay, what happens to the diaphragm during expiration? It relaxes and moves back up. What happens to the thoracic cavity pressure during expiration? Increases. What happens to the ribs during expiration? Moves down and in. If you sit there and you actually kind of like hold your ribs and your kind of thoracic cavity area and you inspire, so you breathe in, you feel your ribs move up and out. You can kind of like notice that thoracic cavity volume has increased. If the volume's increased, the pressure has to decrease, and then you know that air has rushed into the lungs. Conversely, if you then just expire, so breathe out, you can feel your ribs move down and in. You can kind of feel that volume decreasing, which means the pressure increases. And then air rushes out of the lungs. So they're the corner notes for this lesson. If you can make sure you are aware of that, you know it, you can come in and start questioning yourself straight away, that would be fantastic. I'll see you in lesson. Bye.